Hi everyone, this is the Subarray Division 1 problem by HackerRank. The link to this problem will be in the description. So the problem says two children, Lily and Ron, want to share a chocolate bar. Each of the squares has an integer on it. So an integer is any whole number, so 1, 2, 3. It does not include decimal numbers like 1.5 or 2.7. Lily decides to share a contiguous segment of the chocolate bar. So contiguous just means in a row together. So like 2, 2, 1, that's in a row and together. But 2, 3, 2 is not in a row and together because we skipped over 1. So contiguous is in a row and together. Now the length of the segment needs to match Ron's birthday, and the sum of the integers on the squares needs to be equal to his birthday. So this is the birthday, this is the birth month. So we are looking for a contiguous segment, and the segment size needs to be equal to m. So the contiguous segment needs to be a size of 2. And the sum of that segment needs to equal our d, so equal 4. So we see contiguous segment of 2 elements, right? 2 and 2. That equals 4. 2 plus 2 equals 4. So that's one of the possible segments. And then we have 2 and 1, but that equals 3. It does not match, so that's not a segment. We have 1 and 3, that equals 4, so that is also a segment. And we have 3 and 2, but that equals 5, so that is not a segment. So our two segments in this example is 2, 2, and 1, 3. The constraints for this problem, I skipped over the return. So what we're returning is the number of ways the bar can be divided. So in this case, we return 2, because it can be divided into 2 possible segments. Now the constraints for this problem is that the size of the chocolate bar, or the size of the array that we're going to be given, can be greater than or equal to 1, but less than or equal to 100. And the elements in the array, or chocolate bar, can be greater than or equal to 1, but less than or equal to 5, where this basically says that the index, right, it basically can't be greater than the size of the array, which I don't know why they even bothered listing that. And the number of days can be anywhere from 1 to 31, and the month can be anywhere from 1 to 12. Let's go ahead and look at an overview of the solution. So step 1 is to confirm that the number of segments, so the size of our array, is greater than the given month. And the reason we have this check is, right, we need a segment size of m. Right, so if the number of elements in our array is less than the size of segments that we need, then it's impossible to divide the chocolate bar. So just as an example, if we go back here, if our m equals 12, well, there's only 5 elements in this array, so we cannot get a contiguous segment of 12 if the size is only 5. So that's why we have our step 1. Then our step 2 is getting the sum of the first segment. Step 3 is checking if the sum of the first segment equals the birthday, equals d. And step 4 is getting the rest of the segments and check if it equals the birthday. And there's a reason why I listed this as its own separate step, and we'll see why in the walkthrough. So given S equals this array, D equals 3, and M equals 2, we're going to solve for the problem. And we have our count of segments here below, which is equal to 0. Step 1, confirm that the number of segments is greater than the given month m. So is the size greater than m? Yes, because the size is 5 and our m is 2. So we can continue to step 2. If that wasn't true, right, we would just return 0. Oops. Now our step 2, getting the sum of the first segment. So sum of our current segment, or our first segment, currently is 0. So in order to get the sum of the first segment, we have to add the first two elements together because our m equals 2. So we get our 1 and our 2, we add them together, and that gives us 3. Then we check if the sum of the first segment equals the birthday. So does 3 equal our d? And in this case, it does. So we added 1 to our count of segments. Now we need to get the rest of the segments and check if it equals the birthday. So we do this by subtracting the first part of our segment. So let's do that. And that gives us 2, which is the second element, right? And now we can add the next part of our segment. So rather than looping through the array and saying, all right, get this index and then add 2, get this index and then add 2, get this index and add 2, rather than doing that, we can just get the first segment, and then to get the next segment, we subtract the last element of our segment and add the next element in our array. So that's what we're doing here. We're subtracting the first element in our segment, and then we're adding the next element in our segment, which gives us 3. And so we check, is that equal to our birthday? And it is. So we add to our count of segments. And then we do that one more time, right? So we subtract the first element in our segment. Then we add the next element in our segment. It gives us 4. So we check, does that equal the birthday? And it does not. So we do not increment our count of segments. So that means this is our answer. Our answer is 2. So go ahead, pause the video, try to solve this on your own, and then we will solve it together. For our code, the first thing we want to do is we want to check if the m is greater than the size of our chocolate bar, right? And if it is, then we return 0. Now we can declare a variable that stores the counts of our segments. And then we want to have another variable that keeps track of the size or the sum of our current segment. Then we're going to go ahead and jump to step 2 here, where we get the sum of our first segment. So the sum, we're going to need a for loop, and we say while our index I is less than the size of our month, then we will increment I. And the sum of our current segment, we're going to add to it the element at index I. Okay, so this will get us, so if m were 2, this would give us the first 2 elements of our segment. Then for step 3, right, we check if the sum of the first segment equals the birthday. So we're going to do a check if sum of current segment equals the day. If it's equal to the day, then we're going to increment the count of our segments. That completes step 1 through 3. So now we'll have our last step, which is getting the rest of the segments and checking if it equals the birthday. So we're going to need another for loop. And this time our index is going to start at m. Because we already got all of the indexes below m, so now we need to begin at m. Then we'll say while our index is less than the size of our array, we will add 1 to our index. And as you remember in the example, in order to get the next segment, we first subtract the previous element, right? Subtract the previous element, and then add the next element. So that's what we'll do in this for loop. So the sum of our current segment, we're first going to subtract the previous element, so that's going to be I minus m. And then we're going to add the next element, which is going to be plus equals get at our index. Now that we've done that, we check to see if it equals our day. And if so, we increment our count of segments. And then the last step is simply returning our count. Let's go ahead and copy and paste this into HackerRank. And submit the code. Cool, so everything runs successfully. Go ahead and pause the video and try to calculate for the time complexity and space complexity of this solution. So let's start with time complexity. Time complexity is asking what's the relationship between our input and how long it takes to run this method. So this is constant time, right? This runs the same number of times regardless of our input. Same with declaring these variables. Same with this if statement and this return statement. Regardless of our input, it runs the same number of times. But these two for loops do depend on our input. The larger our input, the more times it runs. But how do we describe that in big O notation? So this first for loop, it's going to run O of m times, right? Because we start at 0 and we run all the way to m. So that's O of m. And the second for loop, it starts at m and runs all the way up to the size of our array. So we would say O of s minus m, where s is the size of our array. So let's go ahead and combine this all together. So our time complexity would be O of m, let's start with the first one, right? O of m plus s minus m. And we can reduce this, because, right, I'm getting my m from here and my s minus m from here. But we could reduce this to O of s. So our time complexity is O of s, right? Because m minus m is 0, so that just leaves us with s. And s is going to be where s equals the size of our array. Next up is the space complexity. So it's asking, is there a relationship between how much space and memory is being used in regards to our input? So here we're declaring two variables. We also declare an index I in both of these for loops. And that's it. That's the only variables we're declaring. But the size of these variables are constant. They do not increase in size, right? The number may increase, so the count of segments may increase, the sum of current segment may increase, but the amount of memory that we're storing does not increase. So this is going to be O of 1, so it's constant space. That concludes the solution for this problem. Thank you guys for watching. If you have any feedback or questions, please let me know in the comments.